Bismillahirrahmanirrahim and Assalamu alaikum. I hope that you all are doing fine. This is day 3 and week 3 of class 9th physics. And today we are going to derive the relation of the mass of the earth and variation of g with altitude. So let's get started. Consider a body of mass m which is placed on the surface of the earth, that the weight of the body is acting downward direction. Let's say that the me is the mass of the earth, r is the radius of the earth, and the distance of the body having mass m from the center of the earth is also equals to r. As we know from Newton's law of gravitation that F is equals to gm1 m2 divided by d square, we are replacing m1 as m, m2 as me, and d square as the distance, which is r. So this will be the equation. But as we know that the force with which the earth attracts a body towards its center is equals to the weight. So force is equals to weight of the body, and we know the formula of weight is equals to mg. So we can also write mg instead of F. So equation 5.3 becomes mg is equals to gmme divided by r square. By cancelling mass from both sides, the equation will be g is equals to gme divided by r square. Now we want to find the value of the mass of the earth. So what will I do? I'll move the other values on the other hand side. So me will be equals to r square g divided by capital G, where r is the radius of the earth, which is represented by r. Small g is the gravitational acceleration, and capital G is the universal constant of gravitation, and me is the mass of the earth. The radius of the earth is equals to 6400 kilometer. If I move the point towards the first non-zero digit, it will be 6.4 multiplied by 10 raised to the power 3 kilometer. Now I also know the prefix of kilo is equals to 10 raised to the power 3. The final relation we will get will be equals to 6.4 multiplied by 10 raised to the power 6 meter. So I'll write the value of r as 6.4 multiplied by 10 raised to the power 6 meter in this above equation. We know the value of g, that is gravitational acceleration, is equal to 10 meter per second square, and universal constant of gravitation is equal to 6.673 multiplied by 10 raised to the power minus 11 Newton meter square per kg square. If we solve this equation, we'll get the mass of the earth, which is equals to 6.0 multiplied by 10 raised to the power 24 kg. Or we will also get the approximate value of mass of the earth. So by using this relation and knowing the values of r, g and capital G, we can find out the mass of the earth. Now the next topic we have here is the variation of g with altitude. Variation means change and altitude is height above the sea level. Now in the previous topic, we were saying that body of mass m was placed at the surface of the earth. What will happen if we move the body away from the surface of the earth? Let's say I am placing an object at the height h from the surface of the earth. Now I know that force was equals to mg, and force is equals to gmm divided by r square, which is the gravitational force from Newton's law of gravitation. Now here d square, or we can say r square, is the radius of the earth and the height of the object from the center of the earth. So d squared or r square will be written as r plus h whole square. R is the radius of the earth plus h is the height of the earth from the height of the object from the surface of the earth. By cancelling m on from both sides, we'll get the value of g, or we can say acceleration due to gravity at a height h, which is equals to gm divided by r plus h square, where r is the radius of the earth and h is the height of the object from the center of the earth, from the surface of the earth. Now, as you can see here from this equation, we can see that acceleration due to gravity, which is represented by g, is inversely proportional to the height of the object. We can say that if we are moving away from the surface of the earth, the acceleration due to gravity will decrease. We can also say if the height is increasing, it means the gravitational acceleration is decreasing. And if the height decreases or moving away towards the earth center, the gravitational acceleration will increase. Now let us see that what will be the variation of g if I am changing the height of the object. If I am placing an object at a height of 1 earth radius, what would be the value of g? As we know that gh is equal to gme divided by r plus h square. Now if I am placing an object at a height of 1 earth radius, then h is equals to r. So I'll write r instead of h. R plus r is equal to 2r whole square, and when I'm squaring it, it will be gme divided by 4r square. If you see here, gme divided by r square was basically the value of g from the mass of the earth. You can see here, gme divided by r square. So I can also write g instead of gme divided by r square. So at a height of 1 earth radius, the surface of the earth, g becomes 1 by 4th of the value of earth. Now what would happen if I place an object at a height of 2 earth radius? Let's see. If I am placing an object of a mass m at a height of 2 earth radius, then h will be equals to 2r. And as we know, the formula of gh, or gravitational acceleration at a height h, is equal to gme divided by r plus h square, where h is the height. I am replacing h as 2r. It will be 3r. By squaring it, it will be 9r square. So same, you can see here gme divided by r square was equals to g. So at a height of 2 earth radius above the surface of the earth, g becomes 1/9 of its value on the surface of earth. If I am placing an object at a height of 1 earth radius, value of g becomes 1 by 4th on the surface of earth. And if I am placing an object on the height of 2 earth radius, the value of g becomes 1/9 of its value on the surface of earth. Now we have an example number 5.2, which says, calculate the value of g, acceleration due to gravity, at an altitude 1000 km. The mass of the earth is 6.0 multiplied by 10 raised to the power 24 kg. The radius of earth is 6400 km. So r is equal to 6400 km. H is equal to 1000 km. And me, that is the mass of the earth, is equal to 6.0 multiplied by 10 raised to the power 24 kg. We have to find out gh, or we can say the value of g. R was 6.4 6,400 and height was 1000 kilometer. So by adding it, we'll get the answer as 7400 kilometer. Same, if I move the point towards the first non-zero digit, it will be 7.4 multiplied by 10 raised to the power 3. And by using the prefix of kilo as 10 raised to the power 3, we'll get the answer as 7.4 multiplied by 10 raised to the power 6 meter. So I'll write 7.4 multiplied by 10 raised to the power 6 meter instead of r plus h. Now putting the values from these data, g is equal to 6.673 multiplied by 10 raised to the power minus 11. Me, that is the mass of the earth, is 6.0 multiplied by 10 raised to the power 24. And r plus h was 7.4 multiplied by 10 raised to the power 6. If you solve this equation, you'll get the answer of g as 7.3 to 7.3 meter per second square. Now, your assignment is to solve the mini exercise and derive the value of the mass of the earth.